Okay, cool. Let's get started. So today we're going to focus on the same origin policy, but before I get into it, I want to finish up what we didn't finish last time, a little bit of stuff on cookies. So I'm going to just switch back to the end of that presentation. So if you remember, we demoed setting a cookie on the 106A website, and then we were on the 253 site, and we were able to read the cookie, even though when we set the cookie originally, we specified that we wanted it to only be accessible to the 106A site. So remember, the reason for that was that there's a different security policy going on here in terms of like letting the 253 site access the DOM of the 106A site. And even though the cookie is sort of targeted to this specific path, we're able to basically make a frame and then reach into that DOM. And that's because of the same origin policy. What can we do here if we want to actually enforce a policy like this? Like say 106A wanted to be able to set a session cookie and only have it be valid and accessible on that particular path. So is there something we can do here? Turns out, like, no. There's just not. It's unsafe to rely on path, and we have to expect that cookies can be accessed if we do that. So in particular, what we could do is we could have two subdomains like this. If we had cs106a.stanford.edu and cs253.stanford.edu, these would not be able to talk to each other. So there's some sort of weird kind of cookie rules going on here. So in particular, the rules specified right here. So it's cookies can only be accessed by equal or more specific domains. So the two domains sort of on an equal level can't access each other. But what about this example here? We have 253.stanford.edu and stanford.edu. So based on the rule, what do we think is going to happen here? Should these be able to access each other's cookies? Yeah, go ahead.
It seems like Stanford should be able to access 253s.
Cookies can only be accessed. Oh, so it's actually flipped. Yeah, so it's cookies can only be accessed by equal or more specific domains. So that means Stanford's cookies can be accessed by stanford.edu and more specific. So this is like what they mean by more specific. It's sort of like more things tacked on to the end. Yeah, so it's the former can access the latter's cookies, but the reverse is not true. It's kind of weird, but that's sort of just how the rules are. That's actually a reason why, in the case of the Stanford login system, they put the cookies for that on a completely separate subdomain. So login.stanford.edu is where you go to sign in, and when your password is correct, it puts a cookie on that subdomain, and that means that like the ACM club, for example, couldn't go ahead and read those cookies because again, it's not a more specific subdomain. So yeah, these are sort of separate cookie jars. And then what about this example here, just to make sure we're all on the same page? So which can access which in this example? Mm-hmm. Yeah, go ahead.
Hello can access login, but login can't access hello.
Right, exactly, yeah, that's right. Cool. So because of this, like we sort of just shouldn't rely on path. One thing though is that the default value for this path is actually the path that you're currently on when the server attempts to set the cookie. So if you're on like the 106A page and you don't specify path because I just said don't do that, it's not secure, don't rely on it. So you just omit it. Then it's going to end up giving it a path of the page that you're currently on, which is maybe unexpected. You might want the cookie to be available everywhere, since we're not relying on this as a security mechanism. So let's just not fool ourselves and just let's not use path at all. So what we really need to do here is actually explicitly set path to the root of the site. If you do this, then it's sort of I think it makes it clearer because you end up with the cookies are visible everywhere where they're actually visible. You know what I mean? You're not sort of fooling yourself into thinking that this is doing something. So that's my advice, to sort of always set path to the root. So now this is sort of what our cookie setting looks like. We've done secure so that the cookie is only sent over HTTPS. We've done HTTP only, which weirdly sounds like it's contradicting the last thing. But who remembers what HTTP only does? Yeah.
So that iframes cannot access. So like, oh no, this one is the image one.
Yes, that's the one. Yeah. So basically, if you're trying to attempt to access this cookie from JavaScript, so from JavaScript running in the browser, you won't be able to see the cookie. It'll be sort of it'll be there in the browser, and it will be sent to the server in HTTP requests to the server. But code running in the page can't see that it's there. And this is a nice defense against if an attacker gets code running in a page, then sort of limits the damage that they can do. Okay, so we have those two, and then we throw in path. And so this is better for the reasons I said. So there's one other sort of general problem with this whole cookie design, which is sort of one of the benefits of ambient authority that we mentioned before is that it sort of automatically every request you make sort of has the authority of this cookie, but it can create problems when the browser sort of helpfully includes cookies in requests that you wouldn't expect that it would. So in this particular example, say that we're on attacker.com. Okay, so we clicked a link, we ended up on a sketchy site, and this site just embeds an image that goes to this URL. So this URL is attempting to withdraw from Bob's account to Mallory's account an amount of $1,000. And obviously this probably should have been implemented by the server as a post request, not a GET request. That would be sort of one defense against this. But let's say that it's a GET request. So the browser is going to attempt to fetch this and display it as an image, and the response from the server in this case is probably going to be some kind of JSON or something that's not actually an image. But that doesn't matter. The attacker doesn't care because the request was able to go through to the server. And the browser noticed, you're sending a request to bank.example.com, and it's going to look and see, are there any cookies from bank.example.com? And say that the user logged into bank.example.com in another tab, or maybe 15 minutes ago, so they still have an active session with the server, and so their session ID is valid. The browser is going to attach the cookies for bank.example.com to this request, and then when the server gets it, it's going to look and say, oh, this is like the user's logged in. They have a valid session. Oh, they're trying to transfer some money. Okay, go ahead. It looks valid to me, right? And so this attack site has been able to sort of create a false, like a request on the behalf of the user with the authority of the user, right? So this is really bad. Does this make sense why this is possible? Okay, cool. I see a couple confused faces. Yeah.
In the first example that you showed in the previous class, was that like, I thought it was like the attacker's website, or was this always like a different website that the attacker did not control?
Which example are you referring to?
Like the image is like the same example when you showed it in the previous class.
Was it this?
Let me see.
This one?
Yeah.
Oh yeah. So this is just a method to sort of exfiltrate data. This is just sort of a way to sort of send a GET request to the attacker's server with some information that the attacker wants. So when this request goes through, the attacker will see, request came in at this URL, and they can save that information. It's a little different because in this case, what we're trying to do is we're actually we're on a different website. We're on the attacker's site, so it's sort of the reverse. We're on the attacker's site, and we're sending a request to a legitimate site that the user is actually logged into. And because the browser has this behavior where it tacks the cookies on automatically to any site that has associated cookies, then the server, if it just sort of naively looks at this request, it'll think that it's actually authorized by the user. It's going to see a request come in with the correct cookies, and then it's going to go ahead and do the action on behalf of the user.
So in the first attack, we would need to have the same, to be in the same domain or be a more specific subdomain. Couldn't you intercept, like, since you're the owner of the site, like this HTTP request and just steal the cookies too? Like, just send any request to bank.example.com and just like send also that request to my server.
So you're saying that you're on attacker.com and then you're sending this request to bank.example.com? Is that what you're saying?
Yeah. So I'm like the attacker server.
Okay.
And I'm sending, so now I send the attack to, I send the image to bank.example.com, and the browser would tag the cookies, right?
Are you sending this request from this attacker server?
From the client.
From the client. Yeah, so anytime you send a request from the client to this server, the browser will attach the cookies for that site automatically.
So could I intercept the...
No, you can't. So yeah, that's a good question. So it's a good question. So in this situation, the site that's embedding this image, so the attack site that's embedding this image, it actually can't see the actual request that's going out. The browser's just gonna fire that off, and it's not like it can observe it or anything like that. All it can do is it can actually, there's not really much that it can see. One thing it can do is it can attach event handlers to this image. It can attach on success and on error, and it can sort of find out whether what was returned by the server was a valid image or not. It can detect that, but obviously it's not going to be a valid image in this situation. But that's pretty much it. Yeah.
Can you do the same thing in JavaScript with like AJAX requests?
Yeah, so that's a good question. So we're going to get really into all the nitty gritty of that in the same margin stuff. That's going to in a couple minutes. But in general, no. When you're firing off an AJAX request, actually, we'll just save that for a little bit. We'll get into that in like a couple minutes, I promise. Okay, so this whole idea here is called Cross-Site Request Forgery. And the idea is that the attacker is trying to execute actions that are unwanted by the user, and it's enabled by the fact that the user is currently like authenticated or logged into that web app. So why would you do this? We just gave an example with the bank. So that's like a normal user. You're sort of executing an attack that's forcing the user to perform some kind of request that you want them to do, like transferring their funds or changing their email address or resetting their password or whatever kind of request you want to send. You can do that action on behalf of the user. If you're doing this and the user's logged into some sort of an administrative interface, like maybe they're an admin of a WordPress site or something, you can, that request can be much more damaging. That request can potentially, create a new admin user on their site. Or it could, in some cases, allow you to just run code on the server. If you're logged in as an admin, oftentimes you can just send a request that will just run a shell script on the server as a server user. So it's pretty damaging.
But to create an admin user, for example, the attacker needs to know what kind of paths, endpoints are there at the server, right? So
yeah. So there's a little bit of knowledge that attacker has to have here. They have to first of all know exactly. They have to know what the path is. They have to they're assuming the user's logged in, right? If the user's not logged in, then this request will fail, and things like this. Yeah, it's true. But you can imagine this being used in a phishing attack or something like that, where you send a targeted email to somebody. They're a member of a particular site, or maybe you know that they're a Bank of America customer via some of the other attacks we're going to talk about, where you can learn this information, and then what you can do is you can just target your request specifically to the bank URL that you know that they're a member of, and just hope that they're logged in, right? Yeah. Cool. So and then notice it's really important here that we didn't actually need to read the response to do this attack, right? Because what we actually did here was this sort of response from the server came back, and the browser attempted to render it as an image, which is going to fail, but we don't care. The request was sent, the damage was done. Right, because the server received a request and it sent back a response, so the damage is done. Does that make sense? Okay, cool. So we're gonna just do a little demo of this actually in action really quick. So I really like doing demos. I think they're fun. So let's see here. Okay. Cool. Everyone can see this? Okay. Cool. So so we have here is the code from last time for our bank website, and what we're going to do here is add a path, a new route to it. So just refamiliarize yourself with the code really quick if you've forgotten. This is the most important part right here. Cool. So let's add a little bit of additional functionality to the site to make it more interesting. So right now, when the user's logged in, we just send back this string here. I think we should change it and make it include a little bit of additional HTML. So I'm just going to put it right in line here because that's easiest. So let's make a form, and this form will let the user transfer money to another user. So let's go ahead and make the action of this be it's going to submit to /transfer. So we're going to have to go ahead and write that route in a second. Okay, so we have a form. It needs to have a send amount, which will be an input. Let's call the input amount. And then we need to have a to user to send the money to. let's call that 2. And then, oops, okay, there we go. And then let's just make a submit button. So type equals submit. Is this big enough for everybody? Okay. Type equals submit, value equals send. That'll be what shows up on the button. Okay, let's run the server here. Just make sure that that worked. Okay, so if I log in, cool, I have a send and a 2 now. Cool. Okay, now let's implement the actual route. Actually, let's also add a balances table here. So we'll just give every user a different balance. So we'll go. This will be a map from username to balance, basically. So let's say that. Oh wait, we already have that. Oops, sorry about that. Yeah. Okay, I'm being goofy. We already have balances. Okay. So then now we just need to do transfer. That's okay. Let's do that. So let's add a route called. That's going to be a post. Nice thing about this being post is that an attacker can't use the image trick that we just looked at a second ago, because image tags cause a GET request to get sent to the server, not a post. So that's maybe that will protect us, maybe not. We'll see. Okay, so we're going to say when somebody posts to the transfer endpoint, let's get the session from their cookies. Okay, and then we'll look them up in the sessions table and make sure that they have an active session. Okay, so then this is either going to be set or not set. So let's say if it's not set, so in other words, the user sent a post request to transfer and they're not even logged in, well then let's just tell them to go away, because that doesn't make sense. We can't have an unauthenticated user trying to transfer money. So let's just send them back the string fail and then do an early return. Okay, otherwise, let's actually do the transfer. So what I'm going to do here is so remember in the form here we had 2 fields. We had amount and 2 that are being sent. So what I can do is I can get the amount from the body. And it's going to be a string, so I'm going to convert it to a number. And let's also get the 2 value as well. So the 2 is going to be the name of the account to send the money to. So that'll just be under recbody.2. And that's already a string, so we don't need to convert it. Okay, so now we know what we need to actually do. So let's do it. So we're going to take money from username, which is the logged in user. We're going to decrement by amount, and then we're going to add and we're going to add the amount to the 2 account, and then let's just redirect the user back to the home page to finish things off. Okay. So this is just like a really simple, naive sort of transfer system. Probably in a real system, we would want to do some kind of transaction. So if the server crashed, like right after this line, that we wouldn't have something that, a state that doesn't make sense. But whatever. This is a simple example. Okay, cool. So now let's just test that it works really quick. So the server's already running. Oh yeah, I need to restart it. Okay, I'll do that. Okay, so refresh. Let's log in. Okay, and so I have $500, and I think Bob had $100, right? So let's send $100 to Bob. Cool. Okay, now only log out and just make sure Bob got it, just make sure we don't have any bugs. So Bob, and then Hunter 2. Okay, Bob has $200 now. So it works. Cool. Okay, so there's a problem with this approach. This is, even though we switched to using post request for this endpoint, an attack site can still cause a request to get sent to the server that the server will interpret as valid. So let's see how to do that. So what I'm going to do is I'm going to make let's make another file here called attacker. Okay, let's do that. So I have this file here called attacker, and what I'll do is I'll start a second server here, and this is just simulating a completely different website, right? So what I'm going to do is just start up a server on port 9999, which looks like an evil port number. So that should help us know which is the attacker and which is the target. Okay, so cool. So let's see. What should the attacker do? So let's see. So let's make a page where the page looks kind of innocent. So somebody might come to it and then be sort of browsing around, maybe looking at cat pictures or something, and not realize that this request is being fired off in the background. So let's make it look kind of innocent. So cool cat site, and then I have a cat I already downloaded, cat.gif. Cool. So that'll keep them distracted. Meanwhile. What we're going to do here is I'm going to go to the code. So remember this code here, this form here that includes the sort of amount and the to and all this? Let's just copy that right directly here into the attack site. And we can go ahead and hide it with style display none. So the user's not going to see that this form is even here, right? And we can remove this text. This text doesn't do anything. Let's just clean it up a little bit. So we have the form fields here. And one thing we can do is we can just put a value into it so it's sort of pre-filled with the value that we want. So let's say we want to send $100. Let's see, Alice is the attacker here. So we'll send $100 to Alice. Cool. And then we need to actually submit this form. One other thing we need to do here is the URL is wrong. So we're on the attacker's site. So it's not enough to sort of submit this form to /transfer. That would actually submit it to the attacker's own site, which isn't going to do anything. We're trying to forge a request to the actual target site. So let's actually put in the URL of the target here, which is localhost 4000. So we're on localhost 9999, and we're going to fire off a request to localhost 4000 /transfer. Okay, so now it's actually fired off. So we do script. We'll just put a script in here, and then this is like kind of bad code style, but it gets the job done. So there's this sort of global called document.forms, which just gives you an array of all the forms on the page. And so we'll just use that. The reason why this is kind of bad is because if the form order sort of changes, then you're indexing and you're going to get a different form. But we only have one form here, so it's fine. And then we'll just call submit on the form. So that actually basically clicks the submit button on the behalf of the user, effectively, right? So there's one problem with this right now, as I've written it, which is that the user's going to come here, and sure, they're not going to see that this form is here because we hid it. But one thing that's bad is that when you submit a form, the sort of default behavior of the browser is to actually send you to a new page. So they're going to get kicked off of the cat page that they're on, which will be kind of fishy. So let's clean this up just a little bit. So what we can do is we can take the form here and just we'll copy it out and put it into a different file called attackerframe.html. Can you see that right there? Yeah, so I just have a separate file. And we're just going to paste the same exact code in here. And then what we're going to do is just include a frame that points to that file. And so what does this accomplish? Well, what this accomplishes is that now this frame, it's going to load up that HTML. Here, actually, I'll just remove the style and we can see it in action. So, and actually, I'll comment out the submit button for a sec, so we can just see what this looks like. Okay, so let me go to the attacker's site. Oops. Okay, so so we have our distraction, and then we have our frame. And what's cool about this is now if I click send, then it's going to navigate this frame, but it's not going to navigate the entire page. So that's the idea behind that. It just sort of cleans up the attack and makes it a little bit less noticeable. So okay, so let's see here. So now let's actually just sort of do it completely. So we'll go here. We'll go back to the. So I actually want to automatically submit the form again, and then I'm going to go here and I'm just going to hide this frame with the same CSS as before. Display none. Okay. So now, if I, so let's see here. So we have to start off on. So the way this works is the user has to be logged into. To the bank. So we just check here. We're logged in, right? We're logged in as Bob. So that's great. So now if I go to this site and I actually refresh, let's go back now and check my balance. Wait, that shouldn't have happened. What happened here? So we sent a request to localhost 4000 /transfer, and it contains amount 100 and to Alice. And let's see here. What's the reason why this isn't working? So the server, so the request contained the session ID, which is great. That means the server should accept it, right? Why? Oh, there it did. Okay, I just needed to refresh again. Okay, anyway, there we go. So it looks like it worked. So let's go ahead and refresh the page one more time, and then. Okay, so the bank has other problems, but we can see here that so every time I come to this site, like I don't see anything going on, but every time I refresh, we're gonna keep firing off these requests. So what's the lesson here? The lesson is that forms are also allowed to be submitted from one site to another, and we have to think about how to defend against this. This seems kind of like a problem. Cool. Any questions about this? Yeah, go ahead.
Do you just have like Chrome security settings disabled, or does Chrome actually just like allow this?
This is always allowed. Yeah.
Oh wow.
Yeah, this is always allowed. So this is actually the crazy thing about this is that a site has to sort of actively go out of its way to implement a defense against this, because the defaults are kind of bad when it comes to this. Yeah, that's just a sort of unfortunate reality with the web. Yeah. Mm-hmm.
Do people, let's say for like Facebook, does Facebook use the form for login, or like they use something else for like to facilitate login? Like, do sites actually legitimately
use forms like this? Yeah, they do. They're really, really common still. Yeah. So typically a site will use a form, and then it might do something fancier on top of the form. So it might sort of detect when the user clicks the submit button, and with JavaScript it'll sort of intercept that with its own JavaScript on its own site, which it's allowed to do, and then it might sort of fire off a login request in the background without the page sort of completely refreshing, in order to improve the user experience. But if JavaScript is turned off, then typically like the form will just fall back to being a normal HTML form, which will still work, but it will cause this sort of page flash kind of thing. So people often do this for user experience reasons. They don't want to sort of have the whole document sort of change when you log in, if that makes sense. Yeah. But yeah, forms are still really common. Yeah. Cool. Okay. So let's keep going. So I'll talk about a defense for this like later, but I just want to. I'll mention one right now, but it's actually not a complete solution. So the one I'm going to mention right now is sort of the idea here is there some way that we can remove this sort of ambient authority that the cookie is providing when we know that the request is coming from not our site, from another site? Because if we could do that, that seems like it would solve the problem, right? Like, what if we could just say, hey, like this cookie, browser, please don't automatically attach it when you're sending requests to my server, unless that request originates from a page that's also from my server, right? That seems like it would solve the problem. So basically, the attacker could now do the same thing that we just did, but the browser would say, wait a minute, when I was given this cookie, I was told not to attach it to requests to this server because it's not coming from that same server. Does that make sense? Okay, so let's dig into how that actually works. So this is another cookie attribute called SameSite. So if you attach this, you can sort of solve this problem for the most part. So this is an attribute that prevents the cookie from being sent with requests that were initiated by other sites. So there's 3 settings. The default is none. So it's sort of just the default browser behavior is to always just send the cookies along if they match the request. But you can do lax, which is basically what it'll do is it'll say anything that's a sub-resource request. So that's like an image embedded in a page, or a form being submitted from a page, or anything like that. Any request that's sort of coming from within a page, that's called a sub-resource request. That's different than like I would call the opposite of that would be like a top-level navigation. That would be if your browser actually goes to a URL that you can see in the URL bar. That's a different thing. So just for the sub-resource requests, if those are originating from another site, we want to prevent those, prevent the cookies from being attached. But for top-level requests, we want to let the cookies be attached. So this setting would stop the problem that we just had. If you want to go a step further, you're extremely paranoid, you can go with the strict mode. And what this says is just never send cookies if the user was sent to this site from like another site. This is really aggressive. So in particular, it doesn't even send cookies on top level requests. So what does this mean? This means that if I have a blog post and I'm talking about how much I love my bank, right, which I would never write, but say I did, I could link to that bank's homepage. And if the user clicked that link, the whole browser is going to go to this new page, right? But with the strict setting, the browser is going to say that request actually originated from Feroz's blog, and so don't attach the cookies. So even though that's kind of a completely innocent request, I'm just sending them to the homepage. The fact that it originated from another site, even at the top level, like it's not a malicious request, it's literally just a URL that the user themselves could have pasted into their URL bar. That's not going to send the cookies. This can be a little bit confusing, if you're logged into a social media site and then you click a link, and they have this setting, then you're going to click the link and you might be logged in some other tabs, but when you click a link from someone's blog, you'll end up not logged in that tab. So this is actually kind of almost too aggressive, I would say. But if you're really into, if you're doing something in finance, maybe you want to do this. But this is actually probably the best setting for the average site. Mm-hmm.
So just so I understand, if I create an iframe and set document allocation on that iframe to a site, like that GET request is not a sub-resource?
That is. Because an iframe is considered a sub-resource as well, yeah. Even though it's I guess it's the top level of its own frame, but it's still a sub-resource, yeah. So lax covers like most of the cases. It sounds bad because you're like, oh yeah, I'm like my security's lax, but like it's actually much better than none. Cool. So now this is what our cookie line looks like. It's getting complicated. But yeah, any questions about same site? Yeah.
So if instead the default was lax, what are some use cases that would break?
Oh, if they just made the default lax?
Yeah, or like are there any legitimate reasons why you wouldn't want that?
So yeah, it's a great question. So it would break some use cases. So like one I can think of off the top of my head is, have you ever been on a site and you see like comments by Facebook? So that little box, that's an iframe, right? And that's going to make a request to load this little comment box. And if they turned on same site lax, what would happen is the cookies for that request would not actually get attached, and it wouldn't be able to show you like your avatar there and have a little box that ready for you to type your comment in. Like you wouldn't be logged into the comment box basically. It would be like a logged out comment box. You'd have to type in your username and password for Facebook and also your comment in order to make that work. So that's a little annoying. Yeah, that's one thing. Another thing is like ad tracking. They don't want to turn this on at all because they basically attach cookies to every request for an ad, so they can know that it's you. And they're very happy to have that tracking information attached to every request. So they would be unhappy with this change probably. But yeah, I think those are two use cases that would break. But actually, the thing that's interesting is these aren't actually that good of use case. Like people are sort of the threat of like this attack plus like people's concerns about tracking are actually sort of changing the calculus around this. And there's actually now a proposal by Google to just make same site equals lax be the default for all browsers. So yeah, this is what it says. So first, cookies should be treated as, this is basically a snippet I pulled out of the spec that they proposed. So cookies should be treated as same site equals lax by default. Second, cookies that explicitly assert same site equals none should also be marked as secure. So the first part is what I already said. It's basically that lax would become the default. But the second part is kind of interesting. This is sort of Google's attempt to solve like ad tracking, which is their idea is so if this is the default, if lax is the default, then the only people who are doing same site equals none are probably ad people or maybe something kind of a little bit more sketch. So let's force all those cookies to be marked as secure. So at the very least, that tracking data is going over HTTPS, and people can't passively observe it. If that wasn't true, then in theory these requests would have this tracking data attached that anyone on the network, like your ISP or the NSA, could read and then learn that it's you, right? Because this data is being sent in the clear. So this is sort of like a slightly better situation. But yeah, so this is a kind of a good improvement, I think. Cool. Any questions? So I think this is going to roll out soon in Chrome, which is kind of exciting. Okay, so one last thing. So how long should you set your cookies for? I mentioned last time, like 30 days is probably sufficient because you can sort of reset the counter every time the user comes to your page by sending them this set cookie header again, and it will sort of it'll be 30 days from that moment on. So now if we add that in, this is sort of what our cookie is looking like. So now what I want to do is actually want to go in now to our server, and I want to add all these options that we talked about. So Express has this nice sort of API for enabling all these features on our cookies. And so let's go ahead and add that and see if it fixes the attack. But one thing to note is when you actually go to clear your cookies, you remember how we do that again? We give the cookie with the same name, and then we tell it that it expires in the past, and then the browser clears it. We have to make sure that all the other attributes are also exactly the same as when it was set. It's a little bit janky because if you don't do this, the browser thinks that it's actually a separate cookie with the same name. And you can actually have multiple cookies with the same name that have different attributes. So anyway, you have to just make sure these are equivalent, except for the max age, right? Because that's going to be set to the past, so we don't have to pass that in. But everything else has to line up exactly. Okay, so I'm going to go ahead and try that. So let's go to our server and try to do this defense. So we're going to go in here and we're going to say, okay, set our cookie. When we set it, we're going to make it be, what do we say it was going to be? It was going to be, so I want to do secure true, but I can't do this because we're running on localhost, which is, I just have an HTTP server. So I'm going to go ahead and omit this particular option, but we could do that on a real production server. But I'll do the rest. I'll do HTTP only to protect it from JavaScript. And then I'll do same site. In particular, I'm hoping that this one is going to actually protect us against the CSRF attack. And then let's just set a max age, because why not? So 30 days, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute, 1,000 milliseconds. That's 30 days. Okay. And then when we clear the cookie, we have to pass, like I said, this sort of same options. So let's do HTTP only true and same site lax. Okay, and I'll just omit secure again because we're not doing that. Cool. All right, that should be it. So let's see if it works. So I'll just restart these servers for good measure just to be sure. I'll refresh my bank, log in as Bob, right? Because Alice is the attacker in this case. So okay, Bob's balance is back to 100. Hooray. Now we come here. We'll refresh the page. And now let's take a look at the, well, let's just check our balance first. Refresh. Oh, what? It didn't work. What the heck? Okay. See if we can debug this live. What happened? So HTTP only is on and same site lax is on. What gives? What? Okay. Let's see. As far as cookies are concerned, I mean, yeah, it's still localhost, but I don't think that should matter because same site is defined as, okay, let's see if we can, all right, I'm going to do some real-time debugging here. I'm going to check this out really quick. Okay, this is not specific enough. Might need to dig into the spec to see what happened here. So our cookie was attached, despite the fact that it was same site. Maybe this is because. Actually, no, I can't figure out why it would do that. Closed. It could be that same site is because it's localhost. Here's one thing we can do. I can actually I don't want to do this. I don't do this live. Okay. Well, go ahead. Suggestions.
The request that you're making, like you said something about like lax allowing for top level resources.
Is a frame top level?
Well, I don't
Yeah, I mean, okay, maybe that's what it is. Like, let's just see. I don't think that's the case, but let's rule it out. Okay, so I'll do this again. So cookies, I should have. Let me just delete this. Refresh. Alice, Bob, Hunter 2. Okay, so now I've been given a strict cookie, and now I'll refresh this, look at the transfer request, and the request header still includes the cookie. Okay. Okay. Well, I'll debug this offline, and I'll get you guys an answer next time about why this is happening. Mm-hmm.
Wouldn't that be because like they have the same IP and under the domain as the
So cookies, the cookies, and also same origin policy, which I'm going to talk about in just a sec, don't actually care about the IP. They only care about like the domain itself. Yeah. And in the case of same origin policy, we care about a couple of the other things in the URL too. But yeah, maybe what's going on here is it's because the domain is the same, and cookies might be looking at that. But I'll get you guys an answer next time. I'm not sure why this happened. Uh-huh.
Does the sec fetch site, same site, give any clues, or is that useless?
Oh, that's actually very useful. So these are sort of options. These are sort of new security headers that the browser attaches to help you figure out where a request is coming from and like how it was triggered. So a site can make more intelligent decisions. And you're right, it does think that it's the same site. So I'm guessing this is because of localhost. Okay, here I'll just try one thing really quick. So we're back in action. So what I did was I basically just added a mapping from attacker.com to my local computer. So if I type in attacker.com now, it's going to actually just fetch a page off of my own computer. Okay, so now let's see what happened here. Sec fetch site is now cross-site, and the cookie's not sent. So yes, thank you. That's it. Yeah, cool. So okay, so let's see what the balance is at now. Okay, so well, it's probably at 0 because of the other one succeeding. But if I refresh this a few times, now I come back here. It's okay. Those requests are not succeeding. Excellent. Okay, so this is because cookies are looking at just the domain, not the whole origin. Okay, excellent. Cool. So just final thoughts on cookies. So cookies implement sessions. Never trust data from the client. Ambient authority is useful, but it opens you up to some risks. And if you remember only one thing, set your cookies like this. Cool. On to same origin now. So, all right, for same origin policy. Basically, the idea here is we want to think about what do we want to allow, what do we want to deny. So let's go through some scenarios. Should site A be able to link to site B? What do we think? Should we allow this? Yeah, I mean this is the way the whole web works. So yeah, this is too useful to not allow it. Okay, should site A be able to embed site B? What do we think? Yeah. Okay. Anyone think no?
In some instances, no.
Yeah, it kind of depends. Like, I don't know. This seems like it's kind of useful sometimes, but it could be kind of dubious. Like maybe, I don't know. Maybe you can do something bad with this.
You can embed an iframe of like, I don't know, Facebook.com and have like an invisible layer on top that keeps track of like someone typing in your password.
Yeah. So this could enable some sort of maybe weird interactions between the sites. So yeah, this is maybe not. I don't know. Maybe not a good idea. Should site A be able to embed site B and then go into that frame and modify its contents? Probably never, right? Yeah, this seems kind of bad. What about submitting a form? I think we just saw that's kind of a bad idea, but yeah, that actually seems like it's allowed. Should site A be able to embed images from site B? It seems like it's probably more useful than not useful, but I don't know. Who thinks no? Why?
I was just gonna ask, like, is embedding really that useful?
Is embedding resources from other sites useful?
Right. It doesn't seem so fundamental the way linking does.
Mm-hmm.
And I just can't think of in my head a time where there's absolutely no way around it, like from a product standpoint. Like the design has to be embedded.
Mm-hmm. Yeah, I think that's valid. Yeah, I mean, it's kind of useful to be able to like link to someone else's image on your site, so you don't have to like re-upload it to your own page. But yeah, I mean, if we were doing this again, and maybe we would just design things so that everything is isolated from everything else, and the only thing you can do is link, and then you could sort of peel off the security if you want to. But yeah, we can't go back and do that now. Was there somebody else raising their hand? Mm-hmm.
I was gonna say one good case for allowing embeds is like in the days of jQuery, everybody just embedded the same jQuery, so it was cached to everybody's router, like the same version.
Yeah, that's a good use case. So this is the CDN use case. So the idea here is, say that every site is just including the same JavaScript library that helps them build their site. You can just have all the sites just reference the same URL to this file, and then once you've been to one site that uses it, it'll be in your cache. So the next site you go to, it'll be like, oh, we already have that file, and the sites will load faster. This is like less useful these days because people often, the builds are so complicated and there's so much custom code that you can't really get much reusability across sites. But yeah, that was useful at one point in time. What about embedding scripts? Should I be able to embed a script that another site published into my page? I mean, yeah, I don't know. So it seems like, okay, there's some shaking heads. What about reading data? Should I be able to read another site's data? Okay. Well, okay, let's go ahead and go through and see what does the same origin policy actually say, and what does it allow. Okay, so this is the fundamental security model of the web. If you remember one thing from this class, this is the thing to remember. The key idea is 2 pages from different sources should not be allowed to interfere with each other. So if we can accomplish this, then this seems like a sort of a good philosophy to have when we're coming up with all the different security rules we want to have. So yeah, I'll just say it again. So 2 pages from different sources should not be allowed to interfere with each other. Now this gets complicated when we actually think about what do we want to allow and what we don't want to allow, like we saw from the list of questions before. It's not so clear. But at a high level, if you think of the web as an operating system, then we can think of an origin as like a process in an operating system. So the job of the operating system kernel is to keep processes isolated from each other so they can't interfere with each other's memory contents or interfere with each other in other ways. And the browser is going to perform this role for us. So the browser is the operating system, and then every different origin is going to be a different process, basically. So we're relying on the browser to actually enforce these rules. And if the browser has a bug in its implementation of the same origin policy, then anything could happen. So we really need the browser to do this right. So the basic idea is, given 2 separate JavaScript contexts, one from this origin and one from that origin, you should not be able to access the other if the protocols, hostname, and port associated with each of those, the other way around. If the protocols, hostnames, and ports of those 2 contexts are the same, then they should be able to access each other. So we call this tuple of protocol, host, and port an origin. So just a reminder, this is what the URL looks like. I showed this slide on day 1. And specifically, if the protocol, the hostname, and the port are the same between 2 different contexts, then they are allowed to interfere with each other as much as they want, basically. So this is the part that we care about when we're judging whether something is the same origin or not. And this is like, just to drive the point home, it's not that, like, the implementation of it is not that complicated. You could write this function yourself to decide whether 2 URLs are same origin to each other or not. So that's one nice thing about the same origin policy, is it's pretty easy to understand and to explain. But it gets confusing when we actually think about, okay, so say that 2 sites are actually different origins. When do we exactly want to sort of enforce different security checks? And how do we define where a document begins and ends? And I don't know, I have what is an origin on there, because we just defined that. But how much interaction do we want to allow between origins that don't cooperate with each other? So I thought I would just show another little demo here. So I'm going to go to the 106A page again, click on them again, and what I want to do here is just I want to go to the 253 page, and I want to just remind ourselves that last time we did this thing where we created an iframe and we put it into the page. How come I can't tab that? Okay, yeah. So we created an iframe. We set it to the 106A URL, and then we did this to add it to the page, and then it got added, and we were able to load it. So even though these are these are actually same origin. That's what we said last time. So the protocol and the host name and the port are the same between my site up here and 106A. So basically, it's anything goes. I can do anything I want to this page. I can I can go into it and delete elements, modify things, etc., etc. But what do we think will happen if I do the same thing here, but I do it for a different page? Let's do crypto.stanford.edu. let's see, how good is their security? So append this to the page. So wait, do we think this is going to work or not? No? It's another origin, right? So we maybe think it hopefully wouldn't work. Worked. Okay, so what does this tell us? This says that actually sites that are different origins are allowed to embed one another. That's interesting. Now, can I do the same thing I did before to the 106A page? Can I do iframe dot content document dot cookie to see all of its cookies? Does that work? Oh, interesting. No. So if I try to actually see what happened here, the document is actually set to null. So I can't touch the document of that page. I'm allowed to embed it, but I can't reach into it and modify it. Okay, good to know. Okay, what else? What else can we do here? Do we think I'll be allowed to do this? Could I reset the source of it to a new destination? So let's see. Before I do this, let me just do something really quick. Let me make this iframe less annoying to work with. I'm going to just quickly sort of make its width a little bit more reasonable. Okay. So now, okay, cool. So I actually have kind of a bigger window to work with here. So say the user sort of is like, let me learn about Dan, read about Dan, blah, blah, blah. While that's happening, do you think that the site should be able to run this code, sort of change the destination of the iframe? Okay, who thinks yes, it should be allowed? Hmm?
Should be allowed? Or why should be
Yeah, why?
Because you created the iframe inside.
Uh-huh.
So you're in control of it, right?
Mm-hmm.
You just created it.
Well, I wasn't allowed to go into it and change it, but you still think I should be able to change its location?
Yeah.
Okay, who thinks no? I shouldn't be allowed to do this. Mm-hmm.
You could potentially change it to a fake version of that site, and embed that instead, while they think they're still on the same site.
Yeah, I mean, hopefully they would look at the URL and see that they're on the 253 site right now and not on Dan Bonnet's site. But yeah, that seems like a concern. So let's see if it works. So if I hit enter, what do you know? It works. So even though this is a context that's another origin and I'm not allowed to modify it, I still can navigate the frame as a whole. That's kind of interesting. Okay, what about, let's do one more thing. What if I use the fetch API, which is a way to sort of fire off an HTTP request? And what if I fetch, let's fetch, how about access? See if I can, actually, let me just refresh the page here to emphasize that we're not doing anything with the frame anymore. The frame is gone. What we're doing here is we're on the 253 site, and the 253 site just happens to be interested in data from access in order to serve its functions. So if I run this, do you think I should be able to read the response that this site sends back and maybe do something with it? Should I get back a string and be able to see what's in it? Yeah? Why do you guys think that I should be able to? Thoughts?
Just linking to our site, right?
No, what I'm doing, I'm actually not navigating the window. I'm trying to get back a string that I can sort of look at the HTML that I could see if I were to say, if I were to visit it directly and then view the source. I'm trying to sort of do that, I'm trying to get this back as a string, and then do something with that string. Seems reasonable? Okay. Well, let's just see what happens. Okay, so got a really scary message. Access to fetch at access.stanford.edu from origin web.stanford.edu has been blocked by Core's policy. So what this is saying is that the browser was going to attach my access cookies to this request, and it was going to fire it off, and then because of that, it doesn't want to actually give me back the result. You can imagine if I did this for something like Gmail, right? Just think about what's going to load when I go to Gmail in my browser, all my emails, right? So it doesn't. You really don't want to let an arbitrary site make a request to Gmail with your cookies attached and get back this sort of page that's full of personal information and let a different site read it. This is very different than my own server could make a request to Gmail. I mean, anyone can I could curl Gmail here if I want to and just sort of see what is Gmail going to send back. Oh, I guess it moved, but I mean, obviously anyone can make a request and moved again. Okay, keeps moving. Oh my gosh, are they serious? Oh, it's trying to log me in. Wow, that's why it's so slow. It sort of redirects to redirects to redirects. But anyway, the point is, eventually this would give me my emails back if I was logged. Or no, sorry, it wouldn't give me my emails back because my browser cookies are not being sent with this curl request, which is why it's no big deal. But in the browser context, my cookies are going to be sent, and I'm going to get back all my emails. So we don't want to let other sites see that.
So this is enforced in the browser. So like Chrome and Firefox could have different policies, or even different versions of Chrome could allow some of this.
Yeah, we're relying on the browser here, but fortunately, when it comes to the same origin policy, this is like since it's the most fundamental security model of the web, it's implemented pretty consistently across browsers. There have been a couple of sort of implementation bugs that have happened in the past, and I hope I have time to, not today, but in the future, I hope I have time to mention one of them that was really interesting. But yeah, for like by and large, this just works like pretty well. It's like sort of this same origin policy I believe was created a year after cookies were created, so like 1995. By the way, that explains why they diverge in their definitions, right? It's because same origin policy came after, but it's really old and it's really sort of stable and everybody agrees on it. Yeah.
Sorry, so when you're executing stuff in the console there, I thought it's coming like locally. So I guess I'm confused why
Why the cookies are not attached?
No, like why can't you just fetch any site and it's like that say I guess it's confusing to me because it's not Gmail, it's saying no, you can't access me. You can't fetch. It's the browser saying that.
Yeah, the browser is saying that, so in the browser, right, if I go to, actually I probably shouldn't show this on the screen. I was going to show you my Gmail cookies, but that would be a bad idea. But if I were to go to Gmail and then open up this sort of cookies tab for it, you know, we would find a bunch of cookies for Gmail here that identify me to that server. And because the browser was going to attach those to the requests, that means that the response that comes back could potentially be, you know, personalized to me, right? And the browser doesn't want to let an arbitrary site do that.
So it's not that the browser is trying to prevent you from logging in the console and doing your own thing.
Yeah,
Instead, it doesn't want that code being executed from the site that you're loading.
It doesn't want it to be executed with the ambient authority of my cookies, right? Now the thing that's really maybe a little confusing to you guys about this is that we just saw like a second ago that I can submit a form across origins, right? That's what we did. That's what that attack just was before, where that attacker.com caused Bob to transfer $100 to Alice, right? That is like not intentional. That is like a bug, basically. That is sort of an artifact. Like if we could do it over again, we would have everything follow this same origin policy. That's just sort of an exception to it for backwards compatibility reasons. Of, you know, forms were able to do this in the early days of the web, and nobody has sort of wanted to break that ability, even though it does seem to sort of fly in the face of this same origin policy, because that is literally, you know, site A submitting a form to site B, right? But that's how it is. Yeah, in the back.
So, is this because Gmail's, is the reason it's not working is because Gmail's cookies are set with the same site equal to last? I'm wondering, would this work if the Gmail's like session ID cookie or whatever was set to same site equal to none?
No. So it's literally gonna block any site. Like I could try anything here. Anything, you know, whatever I put in here is gonna fail because it's a different origin. So this whole API just sort of perfectly enforces the same origin policy. This is like a newer thing, so we were able to sort of just be like, we're gonna do this one right. So this one behaves the way we'd expect. Different origins can't interact with each other. Yeah. Now there are ways to sort of opt out of this. Like if you're building some kind of an API, you know, and you want to allow developers from different sites to interact with you, you can relax the restriction. But the default is what we want. It's defaults to being secure.
So like same origin policy, using this API, same origin policy like takes precedence over like the same site cookie setting.
Yeah. Okay, I think I need to move on. Okay, so cool. So yeah, a quick review. So are these two sites going to be same origin or not? Yeah, they are, right? Because protocol and hostname are the same. What about these two? So just shout it out. If you have an answer, shout it out. No. Yeah, because www.example.com is different than example.com. So these are actually different origins. Yeah, a little intuitive, but that's the way it is. Host names do not match. What about these two? Protocols are different, right? Okay, what about these two? No, ports are different because the default port is 80. What about these two? Yes, yeah, so they're both 80. Okay, cool. So the problems with same origin are sometimes it's too narrow, so sometimes it's restricting us too much. In the case of like login.stanford.edu, maybe it wants to cooperate with access. Maybe it wants to allow access to read the login.stanford.edu cookies. The way the same origin policy works, this is, or I guess this is more like cookie policy, but yeah, these aren't allowed to exchange data. And then other times we find the policy is actually too broad. It allows too much stuff. So for example, with the 106A site and the 253 site, because the origins are actually the same, but the actual sites are owned by different organizations, we might want to sort of specify, like we want to keep these separate. Well, the same origin policy doesn't give us a way to do that. So sometimes it's too narrow, sometimes it's too broad. But yeah, this is what we have to work with. At least it's consistent and at least it's simple. And then of course the other problem is sometimes it's not enforced for certain legacy web features, like form submissions and we need to know which things in particular it's not enforced for. If we don't, then our site will be vulnerable. So let's talk about a couple of ways to relax the same origin policy when we want to cooperate with another site. So we need an idea. The idea is we need a way to sort of two sites to sort of say we like each other. We want to talk to each other. How do we do that? So one idea is this is actually a really old API that people threw into the web as a sort of way to do this. But unfortunately, it's a really bad idea. It has a lot of problems. But we're just going to go over it just quickly so you can see why it's such a bad idea. And in case you see it, you'll know to be scared, basically. So the idea is, it seems like a good idea at first. The idea is, okay, so say login.stanford.edu and access.stanford.edu want to cooperate with each other. So they can both run this line of code, which says, hey, for the purposes of the same origin policy, please just pretend that this is my domain. Okay? Now, you can't set this to anything, right? Because that seems like it would just break everything. So all you can do is set this to something more general than your domain. So you can login.stanford.edu, you can sort of chop login off, and it can pretend that it's stanford.edu. In fact, you can even chop off the Stanford part, and you can pretend that you're edu, and let anyone, any other edu site interact with you. Probably a bad idea, but you can do that. So the idea is both of the sites have to opt in, and so the like one obvious problem with this is some other person like attacker.stanford.edu can also sort of join the party. They can say, oh, hey, I also want to be treated as stanford.edu, just like those other two pages. And now suddenly, wait, then attacker still cannot access content. Oh, right. Yeah. So yeah, that's a problem. But what this is saying here is actually slightly different. What this is saying is to say that Stanford.edu didn't run any line of code here. So Stanford.edu just didn't do anything with document.domain. Could attacker.stanford.edu decide, hey, I want to be Stanford.edu for purposes of the same origin policy? It turns out actually no. So Stanford.edu itself has to also agree to opt into this, and the way it does that is by setting its own document.domain to Stanford.edu. Now this might seem kind of silly because you think, isn't Stanford.edu's domain already Stanford.edu? So it turns out like this is not an OAuth. This is actually significant. This is sort of Stanford.edu indicating that it would like to join this sort of party of like anyone who wants to sort of say that they're Stanford.edu. Okay, yeah. So it's a little confusing. The other thing that's really weird about this is protocol and port are also not settable at all. So you have to both be on the same protocol and port. That part of the comparison can't be changed. You can only change the domain. Yeah, question?
And so if I'm on attacker.stanford.edu and this runs and then like a effect request runs, it will grab stanford.edu, run the JavaScript, and then wait to see if document.domain.
No.
Like
how do you know what they set their thing to? Yeah. So this is assuming that there's so if you're trying to interact from attacker.stanford.edu and interact in some way with stanford.edu, you must have like a handle on like a reference to a window that has that other site in it. So that could be like an iframe. If you have a reference to an iframe with the site you're trying to do something to, then that's when the check will happen, is when you try to actually cross that iframe boundary. It could also be that you maybe you open a pop-up window to another site and you have a reference to the window you just opened. That's the same thing. So that the boundary is sort of enforced there. So when it goes to do the check, that page has already ran, and if it has done this, then that changes the rules, right? Yeah, question.
So just to clarify, when like attacker.stanford.eu like sets its domain to that and then tries to access stanford.eu, stanford.eu decides at that point whether or not it wants to opt in based on what?
No. So either at the time that the attacker.stanford.edu is attempting to sort of cross that boundary, if this has been set before, then that will succeed.
Oh, so like if another site, like if stanford.eu agreed to communicate with cs253.stanford.eu and then set its domain, then attacker.stanford.eu could set its domain to stanford.eu, and then Stanford already agreed to that.
Yes. Yeah, Stanford agreed to sort of let anyone on stanford.edu talk to it. Yeah, if it does that. Yep. Yeah, question?
Oh, just to be clear, regardless of any of those, attacker.stanford.edu can by default access all of stanford.edu's cookies, right?
Yeah, that's a good point. Yeah, good check. Yeah, that's because the way cookies work, right? So yeah, yeah, it's a good point. Yeah, but this is sort of like beyond that. You can even do more. Yeah, yeah. Okay, so I think we'll skip this. It's not too important. This is just sort of ensuring that we all understand the way that all the things we just talked about of sort of how setting document.domain or not setting it affects whether something is allowed or not. But you can go ahead and take a look at this in the slides if you're curious. It's not too important. But just to emphasize why it's a bad idea, right? It's that if login and access want to talk to each other, they're going to run this code, and then now anyone on stanford.edu can also run that code, and then they can talk to that page. So this is a problem. Okay, so let's just rule that out. Never use that. Forget about it. If you see it, just be afraid and make sure you look at all the details because something's probably going wrong. So let's talk about another way you might be able to sort of get around the same origin policy if you want to communicate with another page. So again, we're going to try and find a way to get around it. Hopefully it's not as bad of an idea. So what if we create a setup where, so say Access wants to talk to login.stanford.edu. So could Access put maybe an iframe in the page that contains the login.stanford.edu page, and then change. This is so gross. But do you remember the fragment identifier? This part of the URL. Okay, so we just said that iframes can change the source of their. A page that has created an iframe can navigate it to new URLs, right? We just saw that. I set the crypto. I moved crypto to example.com. So what if I do that, but instead of actually navigating it to a new page, I just change the fragment part of the URL? So this actually doesn't cause a page to reload. What this does is it just sort of it jumps the user to a different part of the page, right? Based on whatever this fragment is. But if the fragment doesn't exist in the page, then it actually even does nothing, right? It just won't match anything. So if I did that, and then the page repeatedly checked its own URL to see what the fragment was, we could use this as a communication channel. So this is really kind of ridiculous, but let's just make sure we all understand. So parents are allowed to navigate the child iframes, and if the child can check its own URL, then it can see the fragment identifier changing, and then the parent can talk to the child. Okay, so this is actually the way that we got around the same origin policy for like a really, really long time on the web, because there's no other way to sort of opt out of it for this use case. So we're just gonna show you this for like sort of historical reasons, because I think it's actually just hilarious. So go to lecture 4, live code, and let's actually try to implement this. So I have two files here, child and parent. Okay, so let's go ahead and let's see here. So in the parent, what I want to do is actually let's start with the child. So let's start with the child. So the child is going to let's say its whole job is it's just going to try and display the fragment that it's been given. So this is sort of the message from the parent. So we'll include a script here, and we will just get this div that we just created above, and I'm just going to put into the div sort of the the result of basically the result of what is in the window.location.hash, which is that fragment identifier. And I'm just going to decode the contents of it so that it renders a little bit nicer. And I'm going to slice off this is going to slice off the leading hash. So we just get this stuff after the hash. And I'm going to do is I'm going to repeatedly poll. Yeah, this is, I kid you not, this is how it was done. It's incredible. Okay, so every 10th of a second, we're just going to see, hey, is the hash different? And oh yeah, and then what I want to do when I actually get it, I want to set it to be the contents of the div, just so that we can see it. So I'll just do div.textContent equals that. Okay, so cool. So now, now in the parent, this is going to, obviously this needs to embed the child iframe. And so that'll be, this is going to be now, to simulate that we're dealing with two sites here, I'm going to use a different origin. So the parent is on 4000 and the child is on 4001. Okay, so we're going to include the child, just like that. And now let's create a way for the parent, let's create some mechanism for actually sort of talking to the child. So what I'm going to do is I'll make an input which will have the name val, and then I'm going to make my script sort of, here actually let me add some new lines here too really quick. Okay, so then I'll make my script look at that input value and just pull that off of the input, and I will get a reference to the frame as well. Oops, query selector. Okay, and then I need to now basically listen for key presses on the input. So we're going to listen for an input event, and whenever that fires, we know that the user's typed something into the form. So what we're going to do then is set the iframe source to be, let's basically set it to the same thing that it was before, except for we're going to tack on hash, and then we're going to basically do encode URI component of the input's value. Okay. All right. Everybody follow that? So I'm just going to keep setting its source. And because it's a fragment hash, it's not going to actually navigate the frame to a new page. It's still going to be the same page. Okay. So now if I run this, so how do we run this? So okay, so we need to make sure we're in the right folder. We need to start two servers, one on port 4000 and one on port 4001. Okay, and then what we can do is we can go to, so just to confirm, so the parent is on 4000. So if we visit the parent, it's going to embed the child in an iframe on 4001. So it should just be enough for me to go to 4000 and then go to parent. Okay, so that's what we got. So here's the parent page. It has an input box, and then it has this child iframe. And if I now type in here, you can see that with a little bit of a delay, it's copying over the text. And if we actually, here's the cool part. If you actually pull this open and you look at the iframe, check out the source. So as I type, it actually updates. So that's actually that's cross-origin communication right there. Yeah. Cool. So let's see here. We have 5 minutes. Do I have time to show more things? Yeah, I think we have time for one more thing. So let's see if we can do it. So this is obviously gross. So eventually everybody grew up and decided to actually make a proper API for allowing communication between sites, and that's called the post message API. This lets you basically send any kind of string or any kind of object that you want between two origins. It has some nice features. So one thing it does is if you have a complicated object with like maybe many properties and subproperties and arrays and all kinds of different things in there, it will actually clone that across and reproduce it on the other side. And it'll even handle cycles. So if the object has like something that references another part of it, that'll work. You can't send across functions or DOM nodes or instances of objects, but it works for lots of things. And you can even transfer ownership of an object. So I could send, like, say I have like a gigabyte array of like graphics data or something, and I want to send it to another page. that could be really slow to sort of copy across, because I need to give that page an entirely different copy of this data, because in JavaScript we don't have like threads or any ways of sort of sharing memory. So one thing you can do is, instead of copying that gigabyte array across to the other page, you can use this thing called transferable objects, where you sort of say, I want to basically give this object to the other site, and then you lose your handle on it. You've sort of gifted it to this other origin, and that happens like instantaneously. So you can actually do sort of zero copy transfers of data, but then you lose your reference to the object, which is it's kind of interesting. Anyway, so okay, so let's see how this works. So all we need to do to use this API is just make a couple of changes here. So so how about now, whenever we type, instead of doing this jank thing, what we're going to do instead is we're just going to, on the iframe, we're going to get a handle on the window, and we'll call post message with the message, which is input.value. And then what we put here is, this is the origin of the site we want to talk to. I'll talk about why that's important in a second, but for now, just look at, this is the value that we're sort of messaging into this iframe. Okay, so then what does the iframe need to do? Well, okay, we can remove this stuff. It doesn't need to poll every 100 milliseconds anymore. Now what it can do is it can just register the fact that it's interested in these message events by saying on message, basically. Whenever a message happens, just run this function. And in particular, we're going to update the content of the div with the data that was sent across in that message. Yeah, and one other thing I'm going to throw in here is I'm going to just check where this message came from. I'm going to mention next time, I guess, because we're out of time now, why I need to do this, but really bad things happen if you don't do this. But so all I'm doing here is I'm saying, where did this event come from? If it didn't come from the parent, which is this origin, then just return and don't actually do anything with this message. Otherwise, go ahead and display it. And the parent has a sort of analogous thing on the other end, where it sort of ensures that its message is going to who it wants to go to. Cool. So now let's go ahead and just see what happens here. So I will restart the servers, and we'll see what happens here. So so now if I type in this box and I say hello, you'll notice that the URL isn't changing. So that's great. We're not using the old method, and it's instant, so it's faster and nicer. So yeah, this is one way to get around the same origin policy. If both pages want to cooperate with each other and communicate some useful information, you can use post message. Cool. So I think we're out of time, but thanks everybody. And I'm having office hours now from 3 to 5. So if you have questions, you can come to that. But yeah, thanks. Have a great weekend.